Hi everybody, welcome back. Today we're going to talk about the quadratic formula, and I know many of you actually kind of like this formula because it allows you to just plug things in, but there is a trick to making it a little bit easier. So here's what the quadratic formula looks like. So it's negative b over 2a plus or minus b squared minus 4ac over 2a, where ax squared plus bx plus c is equal to 0. So this might look slightly different from what you're used to, and the reason for that is because most teachers, most textbooks teach this as a single fraction, and I don't. I teach it as two fractions, and it makes it a lot easier. You're also going to avoid a lot of the reducing errors that happen near the end of your calculations, okay? So let's start with something really simple. Let's start with something that actually factors, okay? So how about this? Let's say you're asked to solve this, okay? What that means is that you're being asked to find values of x that when you plug them in here make the two sides equal, okay? The easiest way to solve a quadratic equation, probably the easiest way to solve any equation, is to factor it. Okay, but especially quadratics and cubics and quartics, anything bigger than something linear. So if it factors, then that's the easiest way, right? Okay, so what we're going to do is we're going to factor this because it does factor. Now, once it's factored, it's really, really easy to solve, because if this bracket is equal to 0, then the whole side's equal to 0. And if this bracket is equal to 0, then that whole side is equal to 0. So all you have to ask yourself is, what makes that bracket equal to 0? Well, it's 2. And what makes this bracket equal to 0? It's 3. Okay, now, how else could you solve it? Well, you could complete the square and then solve from the completed square form. Now, that's not the easiest thing to do with this one, just because we've got a 5 in the middle, but it's certainly not impossible. So, because we're going to end up with a fraction, right? So 5x plus the magic number plus 6 equals 0. Take the middle number, divide it by 2, get a result. That is my result, right? Never go to decimals here unless the question started off with decimals. Because if the fraction doesn't terminate, this one does, but if it doesn't, then you're stuck with something like 1.3333 to square and then put in here, and it throws the accuracy of your work off. So you want to stick to fractions unless you've been given decimals to begin with. Alright, so we're going to square that. We're going to get 25 over 4. That goes here. Okay? Now, because nothing was factored out, the 25 over 4 is all this has been changed by. So I'm going to subtract it off right there, okay? Then I'm going to write x minus 5 over 2 all squared. Now this math here, we have 24 over 4, that's what 6 is, minus 25 over 4 is negative 1 over 4. Does that make sense? So when I write this part out, I'm just factoring this. Okay, and because this is a perfect square trinomial, this is very easy to factor. What you have is you just have an x at the front of your brackets. It's always going to be an x. That is going to be the sign you write, and then you're going to put half of this number or the square root of that one, whichever is easier for you or whichever makes the most sense for that particular question. And then we have to do this. In order to add these two, you need a common denominator. 6 is 24 over 4. Minus 25 over 4, 24 minus 25 is negative 1. Minus 1 over 4 equals 0. Okay, so now we have the completed square form. Now to solve from here, what we do is we move this to the other side. This is how we solve by completing the square. You get the completed square form, you move the constant to the other side, and then you square root both sides, dividing out any number that might be in front here. We don't have one in this case. So now we're going to square root both sides, and we're going to get x minus 5 over 2 equals plus or minus the square root of 1 over 4, which is 1 over 2. So 1/2 squared is 1 over 4, so the square root of 1 over 4 is 1 over 2, okay? Then we have x is equal to plus or minus 1 over 2, so just that one there. And then the 5 over 2 is going to move over to the other side. And we're going to get x is equal to plus 1/2 plus 5 over 2. So plus 1 plus 5 is 6, which is 3. And negative 1 plus 5 is 4, which gives us 2. So there's our two solutions right there, and they're the same ones we got when we factored, okay? So it really helps to do some of these questions in more than one way, just so that you begin to understand that with math, there isn't one right answer in certain circumstances and another right answer in a different circumstance. There's always one correct answer. There's lots of ways to getting to that answer, but there's only one correct answer. Okay, now what we're going to do is we're going to do this using the quadratic formula. So we have x equals negative 5 over 2 times 1. Okay, so a is equal to 1, b is equal to negative 5, and c is equal to 6 in this circumstance. Okay, plus or minus 5 squared. I don't bother with the negative here because I'm going to be squaring it anyway, so it doesn't matter. However, if you choose to write the negative, make sure that you bracket it, okay, like that, minus 4ac, because if you don't bracket it and then you use your calculator, it's going to be wrong, and a teacher might dock you for writing this, okay, because it's not right. Okay, minus 4 times 1 times c is equal to 6. Divided by 2 times 1, we just carry on. So the two negatives cancel, which gives us 5 over 2, plus or minus 25 minus 24 over 2, 5 over 2, plus or minus 1, square root of 1 over 2. Now the square root of 1 is just 1, so we end up with 5 over 2 plus or minus 1 over 2, which is exactly what I have right here. 5 over 2 plus or minus 1 over 2. Okay, so we're going to get the same answers again. So this was kind of an exercise in demonstrating how when you're solving a quadratic, the easiest way to do it is by factoring it. The second easiest way, it's a toss-up, okay? You could do it this way or you could do it this way, depending on how easy it is to complete the square. Now, if something is already in completed square form like this, by all means do it that way. Don't multiply it all out just to use the quadratic formula. It's a bit of a waste of energy, right? But for, in most cases, if something doesn't factor, like if you're having a hard time finding the right numbers to factor something, don't spend a lot of time, you know, spitballing the right numbers. Just use the quadratic formula, it's going to be easier. Alright, so this one here. Now, it's a quadratic, it's kind of, sort of in that form, isn't it? But what we need to do is rewrite it first. So, because I always want my leading term to be positive, virtually in every situation, okay? I'm going to move these two terms over to this side. That's going to automatically make that term positive. And when you're using quadratic formula, before you start, you always want to make sure your leading term is positive. Let me show you, though, what you would do if it wasn't. So if I move the 4x over, there, now it's in this form. So you could solve it like this with a leading negative, but I don't recommend it, okay, because it just causes problems. So what you're going to do is you're going to divide everything by negative 1. And that is going to make your leading term positive. Now because the other side's equal to 0, we can do this, okay? If it's equal to y, you need to be very careful. Because if you're graphing it, if it's equal to y, you're probably graphing it. If it's equal to y, it's a function. And in that case, you can't get rid of that negative because if you divide it out of both sides, which you have to do, you're dividing it out of y as well, and you're going to end up with negative y, which just doesn't work. So if you have a situation where you're solving, if it's equal to 0, you're solving, then you can do this, okay? And you always want to get rid of that leading negative. So what you're kind of doing is this. You've got a situation that looks like that, and you're being asked, right, because the leading term is negative, and you're being asked to find these points. I'm not saying that that graph represents this, it's just an illustration. And then, when you divide out the negative, you're changing it to that. And so these are still the same, they don't change, right? Obviously your y-intercept and your vertex and so on change, but we're not interested in that here. We're interested in finding the values of x that make this side equal to 0. And it's going to be the same whether it's right side up or upside down. Just make sure that you change all the signs. Okay, so what are we doing? We are solving 4x squared plus 4x minus 5 equals 0. Okay. So a is equal to 4, b is equal to 4, and c is equal to negative 5. So I'm not going to write the formula again, but it's a good idea to write the formula often, because then you get it into your head and you don't forget it, and you don't need formula sheets all the time. So x is equal to negative 4. Now the formula has a negative, but my b is positive, so I don't need brackets there, okay? Divided by 2 times a is 4, plus or minus. So b is 4, so 4 squared, minus 4. That 4 is part of the formula, okay? It's going to appear in every single quadratic formula you write. A is 4, c is negative 5, divided by 2 times 4. Okay. Now the reason I like to make these two fractions is because you can do this very, very simply, very quickly, very easily, and then you just have to deal with that part. And then this part is done. You don't even have to look at it as you're working down, okay? And it makes reducing at the bottom a lot easier. So the 4's are going to cancel, which is just going to give us negative 1 over 2, plus or minus. Now, square your number and then stop, okay? Because one of the biggest mistakes that students make in this whole process is they put the wrong sign here, okay? And you end up with negative discriminants. This number here, remember, is called the discriminant. And if you just stop and think carefully about what sign to write, that won't happen. So don't be automatic about it. Don't go 16 plus or 25 minus. Don't be automatic about it. Just think about what that sign should be before you write it. So we have 4 squared, which is 16. Now, you should never have 3 negative signs, because if you have 3, then you've left a negative. Because remember, this is a, right? And there's my a. My a is positive. Remember before we saw when I rewrote it differently, a was negative. I could have done it that way, but then I end up with a negative underneath, and it's a nuisance, okay? So you're going to have 1 negative always, because the formula's got 1. Or you might have 2, as we do here. You will never have 3, okay? Because you're not supposed to leave a as a negative value. So because we have 2 negatives, we're going to put a plus. Now, 16 times 5 is the same as 20 times 4, right? Which is 80, okay? And then we're going to put 2 times 4 is 8. Now, don't divide this 8 out of anything yet, all right? You can't. First of all, I like to say that this is an elephant and this is a giraffe, okay? You can't divide elephants and giraffes. It just doesn't work. This is a radical and this is a rational number, that 8. So this stuff has to be simplified before we divide that 8 out of it, if we even can. Sometimes you can't. Okay, 16 plus 80, 96. I also can't do 4 plus whatever the square root of 80 is. It doesn't work that way, okay? It's a bedmass problem if you do that. Divided by 8, okay? I still can't divide out the 8 because we still have an elephant here and a giraffe here. So we carry on. Now, how do we reduce root 96? Okay, so if the question asks you for a reduced radical form, you have to take that 96 and you have to remove from it any perfect square factor that is inside it, okay? So 96, well, who knows what 96 divides, how it divides, right? Well, if you're stuck, you can just start with 48 and 2. Okay? 96 also divides by 3, obviously, because 9 and 6 add up to 15, and 15 is divisible by 3, therefore 96 is divisible by 3. It's also divisible by 6. But I choose to start with 48 and 2. Just divide it by 2 if you don't know where to begin. Some small number. Now, 48 is not a perfect square, so we have to keep going. Let's go to 6 and 8 and 2. There are faster ways to do this, but I'm slowing it down deliberately so that you see that other methods work as well. You don't have to find the largest perfect square root right away. This will work too, okay? Now, we're going to go to 2 and 3 here, and notice I'm keeping my square root signs around my numbers. I'm going to do that until I actually take the square root, or until I find a pair, all right? And then I will make them their rational counterparts. Here we have 4 and 2, and that's still 2. Now what we've got is we've got 2 here, rational 2, just 2, right? The square root of 2 times the square root of 2 is just 2. The square root of 4 is 2. So there's 2 rational 2's we've pulled out of this, and this is the square root of 16, which is 4, right? And then these two, because they're not the same, and because they're prime, have to be re-multiplied. So 96, root 96, written in reduced radical form is, we say 4 root 6, okay? So the faster way to do this would have been like this. Now this suggests that you know that 16 times 6 is 96. Not many people know that, okay? That doesn't even immediately come to me. But it is the fastest way to do it. 96, or rather 16, is the largest perfect square that is in 96. And then from there we just go 4 root 6, right? Take the square root, you get your 4, and the root 6 is left over. But notice, we still get there even if we do it the longer way, okay? Okay, so we're going to take this 4 root 6, and we're going to put it over here, over 8. Now you can reduce with that 8, and it's only this number you can reduce with because it's rational, okay? So we have negative 1 over 2 plus or minus root 6 over 2. And that's your final answer, you're done, okay? If you were asked for an answer to the nearest tenth or the nearest hundredth, you would just stop here and stick this in your calculator. But make sure that you go root 96, get the square root of 96 before dividing by 8. Otherwise, you're going to get it wrong. Okay? That making sense? Right, so this one's got a bit of a twist, doesn't it? We've got all these rational expressions to deal with. So don't let this freak you out. Remember, this has to be simplified to look like that. And it's not as hard as you might think. So this particular question will have some teaching about rational expressions as well. The first thing always is to factor. Okay, so that's the first thing we do right there. Now, if a wasn't 1, which it is for all of these, you would take it off to the side and do your decomposition, right? But these are pretty easy to factor, so. Okay, there it is in factored form. Now, when you're solving a rational expression, because that's what we're actually doing here, we're going to be using the quadratic formula because we're going to end up with a quadratic to solve, like a simplified quadratic. This is solving a rational equation, okay? And they have a specific or a special method to use. So again, step 1 is to factor. Step 2 is to figure out what is your common denominator. Now the common denominator must be such that each of our denominators is in the common denominator. So our LCD is x plus 4, x plus 1, x plus 2. So x plus 4, x plus 2, right there. X plus 4, x plus 1 right there. And x plus 2, x plus 1 right there. Now when you're solving a rational equation, what you need to do is you need to get rid of those denominators. So in this, once you figure this out, you're going to multiply every fraction by that lowest common denominator. Now it is a bit tedious to write it out, but I highly recommend it, because if you write it out, it gives you the opportunity to cancel the things that go away, and it's really clear then what's going on. So the x plus 4s, they go away. And what you're left with there is 2 times x plus 1. What happens here is the x plus 4s cancel, and the x plus 1s cancel. So you get, what you're left with is 3 times x plus 2. And here, the x plus 2's go away and the x plus 1's go away, leaving us with x times x plus 4. See where this is going? We're going to end up with this in a minute. So now we have to simplify this. So we have 2x plus 2 plus 3x plus 6 equals x squared plus 4x. We're going to do the math that we can on this side. That gives us 5x plus 8. And on this side, nothing we can do, so we'll just rewrite it. And then we're going to move these two terms over here. That'll leave my leading term positive, because I always want that to be positive. So we have x squared plus 4x minus 5x minus 8 equals 0. And finally, there. That's what we have to solve. Now it's in that form. Now, does this factor? No, it doesn't, because there are no numbers that multiply to make 8 that add to make 1. So we need the quadratic formula here in order to solve it. Now I'm going to run out of room, so I'm going to erase all this stuff. Here's what we're solving. X squared minus x minus 8 equals 0. Okay, quadratic formula is right there. So here's how we set it up. X equals negative, negative 1. Okay, B is negative 1. A is 1. B is negative 1 and C is negative 8 for this question, okay? Divided by 2 times 1, A is just 1, plus or minus 1 squared. Notice I don't put the negative, I don't bother, it's going to be positive anyway. 4 times A is 1, C is negative 8, divided by 2 times 1. Okay, then we carry on. The 1's cancel, so to speak, so do the negatives. So we just end up with 1 over 2 there, plus or minus 1. So square that first number and then stop and count how many negatives you have. We have 2 negatives, which means we're going to be adding. And 4 times 8 is 32, and that's divided by 2. And then this one turned out to be quite easy, because we won't be able to do anything with that radicand to simplify it. There, that's it. So this is it, we're done. Okay, and the reason for that is because 33 doesn't have any perfect square factors in it. Remember your perfect square factors, 1 doesn't count, 1's in everything, etc., right? So when you're listing them in your head, you only have to go halfway. So 25 is more than halfway to 33, and if those numbers aren't a factor of that number, then it's fully reduced. 33, so if you did try it, here's what you'd get. Those are the only 2 numbers that divide out of 33. And when you do that, you go, oh, look at that, they're both prime, and since they're not the same, and you're done because they're prime, you can't divide them anymore, that's it, you're finished, okay? And then you just realize that root 33 is your final answer. Okay, so for this one, we also have some algebra that we have to do before we have it in this form. So let's review, this is polynomial work basically. So anytime you have a minus sign in front of something that needs multiplying, leave that stuff in brackets to begin with, and then bring the negative through afterwards, okay? So we've got 10x squared minus 15x, we're foiling, plus 2x minus 3 is equal to 3. Then 3x squared minus bracket. Get this simplified before you bring that negative through. And then 3x squared minus 10x squared. Now I'm multiplying through that negative 1, okay? Plus 13x plus 3 minus 3 equals 0. So it doesn't look like we're going to end up with a constant here, which means that really we don't even need the quadratic formula to solve this. So just watch what happens. So we get negative 7x squared plus 13x, and the constants, they just cancel away. Now, before you solve any equation, you need to get rid of the leading negative, okay? Because they're just a nuisance. You want to get rid of them. So we're going to take out the leading negative, but we also notice that there is a common x between the two terms. So we're going to factor out negative x, which leaves us with 7x minus 13 is equal to 0. And you can see why we don't need to use the quadratic formula here, because this is factored now. So our two solutions are simply 0 and 13 over 7, right? So 0 plugged in here makes this entire side equal to 0. And 13 over 7 plugged in here, well, plugged in both places because you have to plug it into both x's. But the 13 over 7 in there makes this bracket equal to 0. And because this bracket is 0, the whole side is 0, right? So just to demonstrate, if we use 13 over 7, we have negative 13 over 7. Right, so is that equal to 0? Well, it is, because these 7's go away. And I have 13 minus 13. And so I have negative 13 over 7 times 0. So the reason that the factored form works so well to find the solutions to a quadratic is because when you multiply anything by 0, it's 0. It's called the zero product principle. It's just a fancy word for, or a fancy term for the fact that anytime you multiply anything by 0, it's equal to 0. So when you have a monomial factor, this is a monomial factor right here, this negative x, any monomial factor's 0 is 0, okay? So you could have something as goofy as this, negative 13.25 or 248614 x to the 15 and x minus 3 equals 0. And your two zeros are 0 from this one, okay? Because if you put 0 in there, that whole thing's equal to 0. And the other 0 is 3. Those are your two solutions, okay? All right, so that's it for this video. Thanks for watching, and we'll see you next time.